Welcome to my class. We are discussing about the derivatives. Okay, the question is find the derivatives of x sine x, x to the power sine x. In such questions, we have to suppose or we should take log on both side. We have given y equal to x sine x, taking log on both side, log y equal to log x sine x. And if the power is given, that will be the coefficient or that will be in the product form. Log y equals sine x dot log x. Differentiating with respect to x, differentiating both sides with respect to x, dy dx as log y equal dy dx of sine x times log x. Now dy log y dy by dx, because log y we cannot directly find the derivative with respect to x. That's why we have to find the derivative of log y with respect to y and dy by dx, and in the second part we have to apply the product rule. Okay, so d by dy log y dot dy by dx equals first no change derivative second plus second no change derivative first. The derivative of log I is 1 by y dy by dx equals sine x, derivative of log x 1 by x plus log x times derivative of sine x is cos x. Dy by dx is y times this goes to the numerator in cross multiplication, and taking x common or LCM, sine x plus x times cos x times log x. So just arrange this. Therefore, dy by dx equal x sine x. So the value of y is x to the power sine x plus x cos x log x by x. This is the answer for this question. And you can try the find the derivative of sine x to the power x. You can find the derivative of sine x to the power log x in the same manner. And the second important question, it is very important question. Find the derivative of e to the power x to the power x. The question is e to the power x to the power x. Firstly, suppose y equal to e to the power x to the power x. In this case also we should take log on both side. Log y equal log e to the power x to the power x, and it goes, this power goes in coefficient x to the power x times log e. Log e is 1 because here we have taken log means with base e. That's why log base e of e is 1. That's why log y equal to x to the power x. Again taking log on both side, log y equal log x to the power x, and log y equal here also x times log x. This again x times log x. Log y equal x log x. Differentiating both sides with respect to x, then we get derivative of log y equal derivative of x log x, and derivative of log y, derivative of log y with respect to log y times derivative of log y with respect to dy times dy by dx. Log y with respect to y we have to do that, and log y with respect to log y equal first no change derivative of second plus second no change derivative of first. So derivative of log I is 1 by log y, log y is 1 by y, 1 by log y, derivative of y with respect to y is 1 by y, and dy by dx equal x itself x, derivative of log x is 1 by x plus log x itself log x, and dx by dx is 1. These two can be cancelled. 1 over this y and log y times log y dot dy by dx equal to 1 plus log x. Here remaining 1, here remaining log x, and we need dy by dx equal this y log y goes to multiply y log y times 1 plus log x, and we have suppose y is e to the power x to the power x times log, and y again this y is also e to the power x to the power x times 1 plus log x. Again e to the power x to the power x times this will be 1 as I have already shown, log x to the power x times log e, this is 1. So here remaining x to the power x, first is e to the power x to the power x, second from this part x to the power x, and this is as it is 1 plus log x. In this way we can find the derivative of this question. Now moving to the next question, find the derivative of x to the power e to the power x. In previous question e to the power x to the power x, but in this question derivative of x to the power e to the power x. So firstly we have to suppose y is x to the power e to the power x, taking log on both sides. Log y equal to log x e to the power x, e to the power x times log x. Now no 1 here, and log y equal to this. Now differentiating both sides with respect to x, then we get dy dx of log y equal dy dx e to the power x times log x, dy dx of log y, that d log y, derivative of log y with respect to dy times dy by dx equal first no change derivative of second plus second no change derivative of first. In that pattern we have expand, and log y is 1 by y dy by dx equal e to the power x no change log x derivative 1 by x plus e to the power x, this is e to the power x log x as it is. And here 1 by this e to the power x is common, e to the power x is common, 1 by x plus log x from here, e to the power x is common, 1 by x plus log x in this part, and it y goes to multiply, that is x to the power e to the power x, this is y is here. Now managing this, dy by dx equal x to the power e to the power x times e to the power x plus 1 by x plus log x, this is the final answer. In the same way, we have to find the derivative of log x to the power 10x. In this case, y equal to log x 10x, we have to suppose, taking log on both sides, log y equal to log x 10x, and 10x times log x, log y equal. Differentiating both sides with respect to x, dy dx of log y equal dy dx of 10x times log x. Here, as I mentioned earlier, log y is 1 by y dy by dx. Directly I have done here from the previous experience or from the previous knowledge. First no change derivative of second plus second no change derivative first. We have expanded in that pattern. And 1 by y dy by dx equal first no change derivative of log x into 1 by x, because log x, derivative of log x is 1 by log x into log x is 1 by x, so it becomes 10x times 1 by log x times 1 by x plus log x no change, and the derivative of 10x is sec square x. Now y goes to multiply dy by dx equal 10x over x log x from this first part plus sec square x times log x. Then what is the value of y? We suppose that is, we already mentioned in the first step, log x to the power 10x is y, and 10x by x log x plus sec square x times log x. This is the answer for this question. So you can practice x to the power sec x and sin x to the power cos x in a similar manner. X to the power sec x and sin x to the power cos x. Try yourself. This is for your practice. Now next type of question here, look at here, find dy by dx when x to the power y times y to the power x equal to 1. We have to find dy by dx when x to the power y times y to the power x equal to 1. We have given x to the power y times y to the power x equal to 1. X to the power y equal y to the 1 over y to the power x is y to the power minus x. That's why here I have written directly y to the power minus x. Taking log on both sides, log x to the power y equal to log y to the power minus x. So y times log x equal minus x times log y. Differentiating both sides with respect to x, then we get dy by dx of y log x equal dy by dx of minus x times log y. Now first no change derivative of second plus second no change derivative first. In left hand side, first no change derivative second plus second no change derivative first, but that minus makes it minus. and y times derivative of log x is 1 by x plus log x dy by dx equal minus x times log y 1 by y dy by dx. Log y with respect to dx, but we have to find the derivative with respect to y and dy by dx. That's why it becomes minus x times 1 by y dot dy by dx minus this is 1 log y, and log x dy by dx this term, and we can shift this term also plus, you can shift to the left, so minus x becomes plus or minus becomes plus x by y dy by dx equal minus log y and this term is minus y by x. Then taking dy by dx common, log x plus x by y equal minus common log y plus y by x. Then dy by dx equal minus x log y plus y by x, taking x common, and this goes to divide is y log x plus x by y by taking y common or LCM, y times log x plus x by y here. Then dy by dx equal to, it goes to off is goes to down, so minus y times x log y plus y over x, y log x plus x is the answer. In this way we can deal this problem, we can solve this problem. Okay, now moving to the next type of question. Let's see. Find dy by dx when x to the power m y to the power m n equal x plus y to the power m plus n. This is also in power, but x to the power m times y to the power n equal x plus y to the power m plus n given. Directly we can differentiate this. Differentiating both sides with respect to x is d by dx of x to the power m times y to the power n equal d by dx of x plus y to the power m plus n. And here we can apply the product rule. First no change derivative of second plus second no change. This is second no change derivative of first. Left side is completed. Here you can use power rule. D by x plus y to the m plus 1 by dx plus y plus dx plus y by dx with respect to x. So first no change derivative of second is n y n minus 1 dy by dx respect to dy by dx. So we multiply this for y plus y to the power n times m x m minus 1 m x m minus 1 m x m minus 1 equal power rule m plus n times x plus y to the power m plus n minus 1. N minus 1 means m plus n minus 1 for first part, and second part the derivative of x is 1 and the derivative of y is dy by dx. So here you can see this is n times x to the power m times y to the power n divided by y. The power of minus 1 goes down, y to the power 1 times dy by dx plus, here also this is m x to the power m y to the power n divided by x, similar pattern, equal all this term times 1 m plus n x plus y to the power m plus 1 m plus n, and minus 1 power of x plus y goes down, that is x plus y to the power 1, it goes down, plus all this term multiply dy by dx. You can write the same pattern times dy by dx, m plus n x plus y to the power m plus n over x plus y to the power 1 into dy by dx. Then again from here x to the power m y to the power n, x to the power n y to the power n is common. From left hand side we can take that common, yes, and the yes, that is common. So before that, taking common, x to the power m y to the power n, x to the power m y to the power m is x plus y to the power m plus n. We can do that because here also x plus y to the power m plus 1, x plus y to the m plus 1, either this part or that part we have to replace. Let's see. N x to the power m y to the power n by y. What we did here, sorry, x m y n is x m y n and n, let's see, n x to the power m y to the power n y dy by dx, and this term also dy by dx, so making their group, right? N x to the power m y to the power n over y dy by dx minus m plus n x plus y to the power m plus n is x to the power n y to the power n dy by dx. So in that way, n x to the power m y to the power n by y minus m plus 1 x plus y m plus 1 by x plus y dy by dx, that's shifting and taking dy by dx common, equal. And similarly, m plus n x plus y to the power m plus n by x plus y minus m times x to the power m minus y to the power n by x. And we know this, x to the power m times y to the power n is equal x plus y to the power m plus 1. So this part is replaced by x to the power m minus y to the power n. In this step, what we did, dy by dx, that similar terms have the terms having dy by dx shifted to the left and the remaining terms shifted to the right. This step is that. And here what we did, x plus y to the power m plus n is replaced by x to the power m times y to the power n. So this part is from here, x plus y to the power m plus n is x to the power m times y to the power n. Now the term same, dy by dx equal, here also this part x to the power m times y to the power n is replaced by x plus y to the power m plus 1. Now the terms are as usual. So in this case, x to the power m y to the power n is common, n by y minus m plus n by x plus y dy by dx equal, here also x to the power m y to the power n x to the power m y to the power n common, and here remaining m plus 1 by x plus y minus m by x, and these two terms are cancelled. Then taking LCM, for this question, if you judge x to the power m y to the power n x to the power m y to the power n is common, and here also x plus y to the power m plus 1 x plus y to the power m plus 1 is common, and this is replaced by xm yn, and also you can cancel, and only you can interchange or by the similar way. That is your choice, you can do as you like. So y times x plus y is common here, n x n y minus m y m yn ny dy by dx equal, here also x times x plus y is common, m x n x minus mx my. So these two terms cancel, these two terms cancel. So remaining upper is nx minus my, denominator y times x plus y dy by dx equal, here also nx minus my over x plus y. Nx minus my can be cancelled, and x plus y also cancel. So y goes to multiply, therefore dy by dx equal to y goes to multiply y, x is in denominator, therefore this is the final answer for this question. This is little bit wrong, and you need to think where and when we have to replace x plus y to the power m plus n by xm minus xm times yn. Think in that way and you can solve this question. Now the next question is a dy by dx. Here also we have to find dy by dx when e to the power sin x plus e to the power sin y equal to 1. This is given. So let's take from here e to the power sin x plus e to the power sin x sin y equal to 1. Differentiating both sides with respect to x. Differentiating both sides with respect to x, this is step. And the dy by dx of e sin x plus dy by dx of e sin y equal to 0. Derivative of 1 is 0. and derivative of e to the power sin x is sin x, e to the power sin x, and the derivative of sin x is cos x, plus e to the power sin y is e to the power sin y times sin y is sin y cos y times dy by dx, you know this. And e to the power sin y cos y dy by dx equal minus shifting this to the right, e to the power sin x into cos x. Therefore di by dx equal to minus e to the power sin x times cos x by e to the power sin y dot cos y. This is the answer. And you can try two other question, that is find dy by dx when x to the power y equal to y to the power x to the power sin x equal to y to the power sin x. Please try yourself this question with the help of this pattern. Okay, then let's move to the next question. The question is find the derivative of x to the power 10x plus 10x to the power x. X to the power 10x plus 10x to the power x. We have not given equal to 1 or 0 or anything. That's why we have to suppose, well, this is y or f of x equal x to the power 10x plus 10x to the power x. We have supposed this. Again, suppose here are two terms which are in power form. That's why it is difficult to manage. That's why let's suppose first one is u x to the power 10x and second one is b 10x to the power x, because separately we can find the derivative of these two terms, then we can add at the final. That's why y becomes u plus b. What is u? X to the power 10x, and what is b? 10 to the power x. Now taking first u equal x to the power 10x, taking log on both side, log u equal to log x to the power 10x or 10x times log x. Differentiating both sides with respect to x. D by dx of log u equal d by dx of 10x times log x. Similarly, 1 by u du by dx is like a dy by dx. Here u is used, that's why 1 by u du by dx equal first no change derivative of second is 1 by x plus second no change derivative of 10x is sec square x. Du by dx equal u times this 10x by x plus sec square x into log x. Then du by dx equal to what is the value of u? U is x to the power 10x 10x by x plus sec square x times log x. This is the case first. Du by dx, what we obtain? X to the power 10x times 10x by x plus sec square x times log x. Similarly, for b, we can take b equal to 10x to the power x. Taking log on both sides, in a similar way we can deal this, we can solve this. Log b equal log 10x to the power x, log b equal x times 10 log 10x. Differentiating both sides with respect to x, d by dx of log b equal d by dx of x log 10x. So 1 by b, log b is 1 by b dv by dx equal first no change derivative of log 10x is 1 by 10x times sec square x plus second no change derivative of x is 1. So dv by dx equal to v, it goes to multiply v times x. Now sec square x by 10x, sec square x is 1 by cos square x into 1 by 10x is sin x and cos x goes up. So cos cancel, 1 by cos x is sec x by sin x. So I have written sec square x by 10x instead that x times sec x by sin x plus log 10x. So b is what? 10x to the power x. dv by dx equal 10 to the power x, 10x to the power x times x sec x by sin x plus log 10x. This is the second part. This is the second part. Then we have y equal to u plus b. We have y equal to u plus b. dy by dx equal du by dx plus dv by dx. So du by dx is x 10x sec square x log x plus 10x by x plus dv by dx is 10x to the power x log 10x plus x sec x by sin x, just here and there shifting. X 10x sec square log x plus 10x by x plus 10x to the power x times log 10x, and sec x is 1 by cos x, so 2 times x by 2 sin x cos x. We change in this pattern to make a single term. 2x by 2 sin x cos x means 1 by sin 2x, that is cosec 2x here. Others remaining the same, others term is as usual, and this is 2x times cosec 2x. In this way we can solve this question. Now the last question is find the derivative of 10x to the power cot x plus cot x to the power 10x. In this case also no equal to 1 or 0 are not given in any form, that's why we have to suppose y equal to 10x to the power cot x plus cot x to the power 10x. Again we have to suppose first term is u 10x to the power cot x and second term is b cot x to the power 10x. Then y equal to what? U plus b. Yes, u and b. And now we have to start from u, that is 10x to the power cot x. If this power form is given, then taking log on both side, log u equal cot x time log 10x, that is goes to multiply. Differentiating both side with respect to x, dy dx of log u equal dy dx of cot x times log 10x. Then derivative of log u with respect to x is 1 by u du by dx equal, first no change, derivative of second. What is the second term? That is log 10x. The derivative of log 10x is 1 by 10x into derivative of 10x is sec square x plus log 10x is no change, and derivative of cot x is minus cosec square x, minus cosec square x. Now 1 by u dot du by dx equal cot x is cos x by sin x, 1 by 10x is cos x again goes up into sin x into sec square x is 1 by cos square x, 1 by cos square x, and plus minus minus cosec square x times log 10x. The second term is as usual. Cos square x, cos square is cancelled, 1 over sin square x is cosec square x. From this simplification we find cosec square x minus here cosec square x times log 10x, and du by dx equal u times cosec square x is common, 1 minus log 10x, and u is what we suppose, that is 10x to the power cot x times this is cosec square x times this is 1 minus log 10x, 1 minus log 10x. This is the value of du by dx. Now again we have to find v equal, v is cot x to the power 10x, taking log on both side, log v equal 10x times log cot x. Differentiating both side with respect to x, then we obtain 1 by v dv by dx equal, first no change, derivative of log cot x is 1 by cot x times cot x is minus cosec square x plus